Hello everyone. The topic of my presentation is semi-supervised prototype semantic association learning for robust cross-modal retrieval, which was done by Junsheng Wang, Tiantian Gong, and Yan. I'm the proxy presenter Liangxu Su. And my presentation may include 4 parts. First part, some significance and challenge about semi-supervised cross-modal retrieval are introduced. In part 2, I will elaborate our proposed method. In part 3, I will give an experiment to show cross-modal performance and application studies, followed by a conclusion. And the first part, significance and challenge. With the fast growth of heterogeneous multimedia data on the internet, cross-modal retrieval has gained increasing attention both in academic and industrial areas. Supervised cross-modal retrieval task becomes time-consuming and laborious due to the need to annotate data, but labeling large amount of data is an expensive and time-consuming task. The second one, semi-supervised, may be a good approach to solve the problem, but improving adaptability is crucial for the cross-modal application of the system. When faced with partially labeled data and a large amount of unlabeled cross-modal data. And the challenge, most existing methods ignore that multimodality data contain rich structural correlations, such as intermodality correlations, intramodality correlations, and category correlations. But they do not consider the structural correlations and semantic correlations. Second, some methods use pseudo-labels to fine-tune the deep model. However, they ignore the modality differences, which may lead to inconsistent pseudo-labels of different modalities for samples of the same class. Part 2, ideas and methods. To address the above challenges in semi-supervised cross-modal matching, cross-modal retrieval, we propose a novel semi-supervised prototype semantic association learning method, namely SPAL. And in this figure, we can see that the SPAL contains 3 components: prototype semantic association, pseudo-label guided contrastive learning, and prototype propagation for missing feature completion. And let's talk about the 3 components. The first is prototype semantic association. We were establishing and initializing the semantic associations between labeled and unlabeled data. When C denotes the shared prototypes with cross-modal samples, and K denotes the index of categories. That means we will generate and initialize randomly to generate the prototype C. And the next, we assigned each sample to the prototype it belongs to, using the softmax-like formula, this one. So finally, the cross-entropy loss between the assigned probability and ground truth label is conducted. For the unlabeled data, this is unlabeled loss and this is labeled loss. As the left formula, QI is the score of one pseudo-label, which this sample belongs to. Only larger than the threshold tau will be selected to calculate the loss. And due to the pseudo-label Q in above formula suffer from the problem of confirmation bias because they rely on the model's predictions and accumulate errors. And inspired by co-match, which is a work published in previous conferences, the refined pseudo-label Q can be generated from the neighbors with similar embedded representations in the memory bank. More details can be found in co-match, and it's the same to the co-match. So the second part is the PCL, to make cross-modal representation more suitable for multimodal retrieval tasks. a pseudo-label guided contrastive learning. Specifically, we maintain a pseudo-label graph WL and an embedding similarity graph WS. Then we keep the pseudo-label graph and cross-modal semantic similarity to be consistent by the cross-entropy function. The last is the prototype propagation for missing feature completion, which aims to reconstruct the missing modality features and further improve the robustness of semi-supervised cross-modal retrieval. Due to in the real scenarios, the sample which a text image pair may not available all the time. So this method is to accomplish the missing of the one modality. So we first collect the list of k nearest neighbors in the corresponding image modality. This, for example, is the image, and then complete the missing model feature by this formula, that is the ZIT tailed. So when the alpha ij, the normalized attention score between the current I incomplete samples and all nearest neighbor samples, we can leverage cross-modal share prototype and neighbor features to complete the missing model features, which can mitigate incomplete model data problem. So the third part is the experiments. Table 1 shows the performance comparison of 3 unsupervised models, 12 supervised models, and 3 semi-supervised models. So we in this paper, we propose, the proposed method use only 30% label data and attain results comparable to state-of-the-art supervised cross-modal retrieval methods. This greatly reduces the cost of labeling. The table 2 shows the comparison of cross-modal retrieval performance under different proportions of label data. Our method still performs better than other methods. And the ablation study. We conduct ablation experiments on different components of our method to verify the ideas. See the first row and the second row in table 3. We found that shared prototypes are conducive to establishing the semantic association between labeled and unlabeled data. And for the last 3 rows in the table, we can find that pseudo-label semantic graph can refine the cross-modal representation consistency. And this is the visualization of the effects of different components on 2 benchmark data sets. Only show for 30% label data. And the last is the conclusions. This paper, the main idea of this paper is the following 2 methods. The first is the shared semantic prototypes, which can establish the association between labeled data and unlabeled data. The second one is pseudo-label semantic graphs, that is compared to the similarity graphs, can further refine cross-modal aligned representations. So that's all for my representation. Thank you for listening. If you have any questions, please contact the author, Junsheng Wang. This is his email. Thank you very much.